I know you can do the thing. So, Lethargic Watto, thank you very much for your follow. I appreciate you. You are appreciated, my good sir. Um, what else? So I got my first shirt in. It's pretty great. I would show it to you, except it's not here. I'm not wearing it. I meant to show it to you guys. That was my fault. Anyway, that's fine. I will totally live. So, how are you all doing today? Hmm? So, last week, right? Last week, where we left off was I decided that I am going to make a 68K assembler and a 68K emulator. Why? Because I hate my life. I don't know, because I want to learn assembly programming. Um, and I was going to do it with the Sega Genesis, but the dev kit for the Sega Genesis is in C, and I don't want to use C. And so it's in 68, it's with the 68K microprocessor, so I need to learn 68K. And what best way to learn that than making the assembler and emulator, right? Oh my god, why am I so tired? Oh boy, fuck, I can't talk. This might have to change. I might not be able to do this at night. We'll see. I would do it in the middle of the day, but I'm at work. But today I actually went to Victoria, BC last week. It's quite nice. I enjoyed it. It was fun. Anyway, so we need to start on making an assembler, which means basically taking the mnemonic text and outputting a binary. And then as well, that binary has to be shaped in a way where the emulator will understand it and will read it correctly. So, my question is, so this emulator just takes a bin file, right? So I wonder, is there a way to make a bin file? Is there a certain format that it has to be in? Or anything like that? I have no clue and no idea. I have a viewer. Hello, viewer. Or you're a lurker. I have no idea what you are, but hello. You might be a bot, too. Anyway, so, basically, someone needs to output a bin. So, I need to do this. I have so much stuff here. Oh my god. Sega Genesis. There we go. This one. Oh my god. Okay. Anyway, this one is the giant 7-page one. I was reading about this. So basically, we're just kind of gonna go through this and see. I think the first thing I need to do is, because the input is super easy, I believe. The input is just like, so also because because sorry, a lot of things going in my head at them. An emulator might be a bit harder than I'm anticipating, because the emulator needs to do things. For example, like, you know, if this value is set here, do this thing. I don't know, it'll be interesting. However, so I first know is the first thing is basically I need to make a program that will take the text mnemonics and output them in a binary file in a certain way that the emulator will need to understand. So this text file, however, because I'm making the assembler, I can make the mnemonics kind of whatever I want. So for example, if we do add binary, instead of using the word ADD, I can use the word add binary to make it work. I can have add address, add immediate, add quick, add extended, you know, all this kind of stuff, and logical, stuff like that. So it'll be really interesting. There's a lot of stuff I can do. But There's a lot of stuff here, and I have no fucking idea what it is. Like, I have no idea what I'm doing right now. Because I can make the assembler just fine. I believe it's the making the emulator that I think is going to take a while. That is something I'm afraid of. Why did you go back down? Go to 150%. There. So it's the emulator. So it's like, so right now I just need to know what the binary format has to be. I mean, since I'm also making the emulator, I could decide what the format is of the binary. So I could decide to normalize that. So first I want to see, is there something I can do? List of tables. Oh, they have tables in here. That's actually really cool. I'll Yes. The assembler is used to translate the program written assembly language into machine code. Yes, the source program is the input and the yes, interpreter. I don't need. You're not helpful. The assembler is a more mechanical process of converting the assembly code into binary form. Essentially, the assembler keeps a large table of each possible instruction and its binary counterpart. It combines these opcodes with the register specified in the assembly to produce a binary output file. This code is called object code, and at this stage is not executable. Object code is simply a binary representation of specific input source code file. Good programming practice dictates that a programmer should not put all eggs in one basket, placing all your source code in one file. Okay. Often in a large program, you will separate out code in multiple files to keep the related functions together. Each of these files can be compiled into object code. How would I test an assembler? Guys? How actually would I test an assembler? I guess the best way to test would be just write programs and have an emulator see if it works. Note that even if a program does fit into one file, it still needs to be linked to get certain system libraries to operate correctly. For example, the printf call is kept in a library which must combine with your executable to work. So though you don't explicitly have to worry about linking in this case, there's most certainly still linking in that can happen. Is this C? A practical example. Interesting. After summing with object code, which is being linked together, we can't expect the object code directly as it's in binary form. However, we can use some tools to inspect the object files. For example, read elf symbols. I see. So here we get an object, then we put in, then we link it. Actually involving a linker called LD is a very complicated process on a real system. This is why we leave linking process up to GCC, but of course we're going to spy on what GCC is doing under the hood with the reverse flag. The first thing you notice is this program called collect2 is being called some forever on. Oh my god, it's a lot of stuff. Although the details are complicated, the concept is straightforward. All the object files will be linked together in a single executable file turn. So we need to make an exe for this 68K. And this 68K, I'm assuming read an exe. Um, oh, lectures. That was interesting. The Moto 68K processor has 18 registers that are directly accessible as the user. Those are 8 general purpose registers and 8 address registers, 1 program counter, and 1 status register. All the data registers, all the addresses, and program counter are 32 bits. The status register is 16 bits wide. Only the the data registers are used to store any data. They are general purpose. Because they have been reserved for any specific task by the 68,000 chip designers, they are interchangeable in the sense that whatever you can do with them. The address registers are used to store addresses of locations in main memory. In other words, address registers are pointers to location in memory. Registers A0 through A6 are general purpose and interchangeable. Register A7, also referred to as the SP, is a more special, is processor stack. Oh, that's a stack pointer. It is used by the system to maintain a stack of subroutine return addresses. To be discussed later, you're free to access and modify the context of register A7, just like any other address register. But you always have to bear in mind what A7 is used for. Note that any address register can be used to maintain a stack. Thus, it's possible to handle several stacks at the same time. Note also that although you can store an address of memory location in a data register, you cannot use the data register as a pointer. Cool. It's 32 bits wide because memory addresses in the 68K are 32-bit numbers. The contents of the PC are automatically updated as each instruction is fetched and executed. The contents of the PC are always an even number because an instruction can only begin at an even address. What? The user has a more restricted access to the PC than to data. Okay. This is interesting. What is this, by the way? This is really fucking cool. So most of use are 32-bit wides. They can contain 32-bit numbers. In order to reference a particular bit in a register, each bit is given a number. The convention is that the number of the bits go from 0 to 31, 0 being the least significant, the rightmost, 31 being the most significant, or the leftmost. In other words, the bit numbering 0 starts at the right and goes up. The numbering system is called a little endian. That's cool. This is more detail. The memory space, the memory space of the 68K processor is one big linear array of memory locations, each of them being able to store 1 byte. The memory is said to be byte addressable. Each byte within the memory has its own unique address and can be accessed directly. Note that the memory of the 68K is not bit addressable, which means that you cannot access data in memory bit by bit. This also means that you cannot start reading memory in the middle of a memory location, only at the beginning. Later versions of the 68K processor, like the 6820, allow you to overcome this access restriction. By convention, the memory locations are numbered in big endian order. If the memory space is represented vertically, the memory locations with the small address number are found at the top. As you know, 68K has 32-bit program counter and 32-bit address registers. This is so because addresses of locations in memory are 32-bit numbers, consequently address 2 to 32 locations. Or 4 gigabytes. In order to do so, you need a 32-bit address bus to carry the 32-bit addresses. The 68K and successors 6820 and 6830 have indeed 32-bit address buses. However, the 68K processor as such is a special case, because due to space restrictions, only the first 24 lines of the address bus actually leave the chip and connect it to memory. Address lines 24 and 31 are simply not brought off chip. Since one address line transports 1 bit, this means that only bits 0 to 23 within a 32-bit addresses are used to specify memory location. Oh. For example, if you had a program to access locations to that, you would need to access the same physical location. The state of bits 24 through 31, represented by the 2 leftmost hex decimal digits, simply doesn't matter. In other words, the 68K behaves as if the addresses are 24-bit quantities, not 32. That means that the addressable memory space of 68K is only 2 to the 24 bytes, or 16 megabytes. Note that addresses in 68K are still represented as and stored as 32-bit numbers, even if the only first 24 bits are used. Well, that's interesting. Okay. So this is address instructions. That's fine. Back to top of page. I mean, I would love to hear more about this college person. Sweet. Thank you. I'm going to use this. This is made in 1999. Oh, hell yeah. Emacs, the C programming language. GDB, make GNU software documentation. Software tools. Process terminal and simulator. Bummer. That's fine, dude. Lecture 1. History of computing devices. That is not where I want to go. Okay. 2, 3, 4, 5, 6, 7, 8. Learn how character data is... No. 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 Here's a very simplified model. We have the incrementer, which increments the program counter, mar, the memory address register, which holds the address of the next location to be accessed in memory. The contents of the mar point to that location, for example. Okay. The memory buffer register, which holds the data just read from memory or the data which is about to be written to memory. All information flowing into or out of memory has to pass through the MBR. IR, instruction register, which holds the most recently read instruction from memory while it's being decoded by the CU, which is the control unit. Interprets the bit pattern of the instructions in the IR and is responsible for taking the necessary steps to execute it. Cool. Before actually attacking assembly language programs and the description of how to instruction execute, it is worthwhile introducing the notation called register transfer language, popularized by Hill and Peterson. RTL is pseudocode notation that helps define the actions of assembly language instructions. This notation is very simple. It has very few rules. It mimics high-level languages and helps us greatly understand the flow of data. The fetch execute cycle. In order to see how a computer executes an instruction, we'll break the action into a series of steps. We've already mentioned that computers operate in a two-phase called fetch-execute cycle. During the first phase, the fetch phase of the cycle, the instruction is fetched from memory and brought to the control unit for decoding. In the second phase, the instruction is executed. The first step of the fetch cycle is PC to MAR. This means the contents of the program counter are transferred to the memory address register. Okay. Assembly language is human readable. Mnemonics is on memory. And assembly language. Here's a 68 assembly program. Prime array and the space available for advertisements. Lines starting with an asterisk are ignored by the assembler. CLR.L do D0, D1, D2. I get it. So you can refer to them as their numbers and not actually like, okay. Please don't try to understand what this program is doing. We include it to show you the general layout of the assembly program. Okay, so do you have a start? While for, exit for, increment, else, check, while, and prog. A 68K assembly language is written as a sequence of lines. Each line is written in 4 columns. Column 1 contains the operation label. Column 2 contains the instruction. Column 3 contains the instruction operands, and column 4 is an optional comment field. A word in the leftmost column is the program is a label. This is a label. This instruction. Yes, I get it. The assembler needs at least one blank space to separate different columns. Programs are written in general uppercase letters. You can notice that some numbers are prefixed with a $, some numbers are prefixed with the pound sign, and some are used by themselves. Any number or symbol used to represent the numerical value is prefixed with the pound, which is literal. It means that it's used the actual numerical value. A number without a prefix is the decimal. A number with a dollar sign is treated as hex. And percent sign is binary. Okay. As we said, now we're going to provide you with a listing file created by the assembler for this particular program. As you can see, the listen file contains the text of the program together with some more information. The assembler automatically adds the line numbers at the beginning of each line. Then it gives two columns, that is, columns the assembled code in hexadecimal format. The first of these two columns gives the address of the memory location where the instruction is stored, and the second column gives the actual numeric representation of the instruction. Okay. The same 68K assembly language program can be written in a variety of different syntaxes depending on the assembler that translates into machine code and on the operating system runs on. Unfortunately, there's no way of writing in one assembly language. Okay. The official Motorola syntax and the MIT syntax, yeah, there's different ones. The example of 68K shown above is written in Motorola syntax and is written to run on a University of Tesside 68K simulator. Click here for more information on the University of Simulator and free download that software. Well, I mean, it was made in 1999. Again, please don't worry if you don't understand the program. I see, okay. Alright. Alright, we're getting somewhere. What does my phone want? But guys, we're getting somewhere. We're getting there, I promise you. Shiny Zenny is alive, guys. Did you know that? So what are the future lectures? Address registers, addressing modes, understand the principles behind some basic 68K. Okay. Learn how 1- and 2-dimensional arrays are handled. Learn how various... Oh, right. Alright. Cool. Compiler generated assembly code. Oh. Yeah. The compiling process, interfacing I/O devices, exceptions, instructions, shell scripts, JVM. All right, so there we go. That's interesting. What? Yes, I know you're dead. Shut up, phone. Jesus Christ, I need to buy a new battery for this phone. Yeah. So now that we've done more reading, I guess it's time to do something, huh? Because I'm making the emulator as well. So, if I go to here, la dum bum 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 68K assembler. So now I guess it's time for me to almost like make up the rules that I want in this 68K assembler, huh? Because I can really like, I don't know, because if you go back to here, he uses nprog, right? In like the example he gave, I'm assuming it's a he. I have no idea who did this at all. This is from Candace. CS573 Fall 2002 notes. You know, he used nprog and so basically I guess what I'm looking for is just like, how is this used you know, how, in what area, you know, how to do things almost. I don't know. Again, since all of this is new, there's a lot of stuff I don't know, and it's like, you know, is there like standard like syntax? Is there not standard syntax? Because basically I just go line by line and then I output a file. So here's the thing though, it's the O file. Oh yeah, this is assembly, so I'm making a straight binary file, right? And so I can make the emulator just literally start at instruction 0 at the beginning of the line. Okay. Alright. Okay, here are the rules I'm gonna make, right? Here are the rules I'm going to make. Because I can. Right? Okay, start. To start programming, you need to write start program. To end programming, you need to write end programming. Now, I could do a simple like I read the line and I break it up on a certain subdivision, like, you know, instructions can only be so long. So I guess I could do this. I don't know why I did that. There should be in monospaced font, huh? Start program. Start programming. End program. Cool. That's it. So this is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? Stop adding that fucking tab. Alright, so 13 spaces for the op. Right. Alright. Op code. So basically, I guess the first part would be to go through the file when we need the exe. So if args dot length is equal to 0, console dot write line argument what needs to be the file symbol. So read determines whether to display the press key in the console window. True. Oh, no. That's fine. Console. Right line. Press Q2. Continue. You know what? On this laptop, let's open up Slack and Discord. Maybe some people are talking to me that I don't know about. You know? You know, guys, maybe people actually want to talk to me. Did you ever think about that? I don't think you thought about that, guys. You know, and sometimes you just gotta go, and you just gotta go forward, and that's it, you know? You just gotta be like, just let's go. Like, there's so much stuff I don't know what I'm doing. It's like, you just, you know, you gotta go. You gotta take that step, and so what if you make a really bad thing on the first try? It's for you. It doesn't matter. That's Twitter. Slack is up. Discord is up. And so far, no one has spoken to me. That's okay, guys. I love you too. Alright, so now we have this. So it has to be the file location. This is an int. Why are you complaining? Oh, it's a void. Oh, okay. Just return then. Why isn't main an int? Whatever. String. ASM file location equals args 0. If. Why am I doing all this? I don't know. Using system.io. I like going. I like C#. Path dot exists. File info dot. Okay. File info equals new file info. You know, why can't we just be PowerShell and have a test path? That would be nice. If ASM file. We changed ASM file. ASM file dot exists. If you do not exist, console dot line cannot find the file. ASM file dot. Line, press any key to continue. Console.read key. There we go. Wonderful. So now the file exists. So now we need to read it. So I guess we should have some constants here, huh? Stop adding that fucking tab. Come on. Oh, right, because I'm gonna need to be in the class. Class? Yeah, where the fuck does this go? I don't know. Int. Nope. I can put an int here. Nope, only interfaces. That's cool. Sorry, I've been programming C++ for too long. Const int op code. Cool. Cool, wonderful. I guess if I really wanted to go the OO way, I could make each line an actual object and pass. Oh my god, I could do that. That would be fun, wouldn't it? So, I don't actually play music when I have these headphones on. I just want to let you know that. I've just been recording so much stuff with headphones on that it feels weird not to record with headphones off. To record with headphones off, it's weird. Alright, so now we have this, right? Opcode length 13. So we will need, right? So there's the potential that the start and end don't exist, right? Or there's the potential there might be stuff before the start, right? So we need to find where the starting is. So we need to find the line number where start is, right? So we have a file here. Was this main? Yeah, it's main. Okay. Int static int find start. Is there an open? Open to read a file stream. Yeah, I know, I get it. Okay, let's do this then, because we're fucking lazy. No, I don't want a string. Open text creates a stream reader with UTF encoding that reads from an existing file. No, whatever, that's fine. Dot read line. All right. So technically, it would be faster to text, no, open file stream, stream reader. That's, oh right, I remember how to read files. Oh god, oh, I haven't had to read a file in C# for a long time. Oh god. Stream reader. Oh my god. For each string line in line of assembly in ASM file dot read line that's not gonna work. All right, that's fine. Oh my god, I did this so much way back at the retail lockbox. Oh, yes. Okay, well, not end of stream. Bool at end of stream equals false. While not at end of stream, stream, bool found start false. I know, leave me alone. Come on, what are you doing? While not found start or not at end of stream. String line of emboy is equal to asm file dot read line. There we go. All right, so guys, just to let you know, so I don't know if you know much about scanners or file IO, but basically what happens is every time I read line, the operating system will actually read that line of text and then go to the next line. So basically reads until I get to a new line character, gives me that back as a string, and then goes to the next line. And then when I say read line, it reads the next line. That's how it works. I could roll up a read line by saying read each character until I get to a new line. I could do that if I wanted to. I could also make this fast by going read me the first 13 characters. If it's not start, go around, read me this, right? So I could do that. That's an A assembly, right? If line of assembly dot contains const string here, const string start instruction is equal to start program dot contains. Can I do this one? No, I can't. lowercase. That's really long. So basically we found what we're looking for. Return int line number 0. Return line number. So basically, if we got to here, we didn't find it, so return 0. Oh, so we don't need if we found start or not, because if we find what we're looking for. Alright, so this is start if we are at the end of the stream, false. Also, why is this a boolean? Why not just go asm file dot end of stream? There. Now we don't need that boolean anymore. There we go. No, because my first job, I did a lot of file I/O, like a lot of file I/O. So it's kind of interesting since I haven't had to do file I/O in such a long time. I legit like forgot about file I/O. Kind of annoying. Whatever. Yeah, so that's cool. Alright, so find start. Cool. Find end. Basically more analysis. Find end. That 13 there. Oh no, I'll just do that. Start. This will be end. So I'm going to do this. Const string end. And instruction equals end. Semicolon. So technically what I should be doing is probably doing more some research, maybe even doing some pseudocode, all that other good stuff, right? Fuck that. I don't want to do that. Right now in this code, I just want to program. The reason why I started this weekly thing of that programming guide, the stream, is because I just wanted to code more. I chose C# and I can code in C#, then I can do faster in Haskell. So I'm like, let's do C#. Let's actually code. Let's do something I find enjoyable. So that's why I'm actually doing this. So basically I'm gonna keep programming until I get to a point where I don't I'm gonna keep programming until I get to a point where I need to make it bigger and separate it out into different chunks, like objects. I don't know, maybe if I actually separate it into different chunks like objects, eventually what'll happen is Asmodan is streaming. Cool. Eventually what it can do is make it in C++ or C and make it even faster. It'll be interesting. All right, so now we have this, right? Find start, find end, bool int location equals find start asm file dot. Open text. Now, technically, what I should do is get the stream reader and get the same stream reader, right? And then just compare the numbers. So basically, like if you have a stream and let's say start is in the middle of the file, then I should pass that same location in, so I don't have to read from the beginning again. We'll see. Int end location equals find end. asm file dot open text. All right. Not 0 because 0 is technically the first line, so I'm going to return a -1. Again, returning -1 is not the best thing to do. Technically, what I should be doing is like figuring out. I I don't know, figuring out a good error thing to return, but fuck that. If start location is equal to -1, console.write_line console.write_line start program could not be found. Console.write_line press any key to exit. Key. Right, and this is sometimes what sucks with like object-oriented programming. It's like there's so much error handling you have to do before you actually do anything. It's really annoying. It's like, is my arguments correct? Do I find my start location? Is my end location greater than my start location? All this stuff. And there's gonna be more stuff I'm gonna have to check before I actually do anything. However, at the same time, the checks are here to make sure I'm in a certain state. To make sure the state I'm in is good enough where I can actually do things. So now it's basically the same thing. And now that and the other thing is, like, now that I find myself doing copy and pasting, then I'm like, all right, I'm copy and pasting. I need to start, like, abstracting some shit out. Whatever. End program cannot be found. All right. If end location is less than start location, these should be a line number, start line number, end line number, there we go, start. This is a return. If end line number is greater than the start number, console. What other things do I have in console? What can I do with console? Background color beep. I'm curious. Okay, I'm curious. I'm gonna change this a little bit. Hold on. Console.write_line. Console.write_line. End program is before start program. Okay, all right. I'm really curious right now. I'm gonna try something really quickly. Console app 1. No, you're gonna be not here. See documents. 17. Projects? Yeah, fine. Hold on. I'm going to do this. Because I want to see something. I wonder if I can do this. I'm curious. Okay, that's fine. Cons project 2. Where is the sound? Where is the sound currently coming from? It is in my headphones, so I don't know if you'll be able to hear this or not. That's fine. Static void play every second. Yes, I know. I'm gonna be lazy. Static bool should stop. Source. While shuld stop. While should continue. Using should continue equals. Task.start, task.invoke, task.run. Oh, how do I use this? All right, C# task.run. Cool. Will this work? Come on, computer. You can do this. I believe in you. Okay, hold on. I can't hear it, so maybe it's just not working, which is fine. All right, that's fine. That's not working. Okay, never mind. That was a fun little adventure. Because if I can beep, I was like, well, it matters how fast the beeps is. Because the really cool thing is, excuse me. The really cool thing is, like, then I could get different notes with the beeps. Anyway, so now at this point, the file exists. We have a start and we have an end. Cool. Wonderful. Great. Now, technically, I should start writing unit tests as well, which I'll actually probably have to do. but I don't want to right now because I'm not going to. So I'm not going to, but I should. Anyway, so now that this is here, the next thing is to basically go open text at the certain line number, right? By an offset. And then just literally start reading line by line. So finally, right? Finally, some assembly code. ASSEMBLY. So I'm gonna first start out. First, FIRS start out. Everything is between start and end. I'm probably gonna keep it that way. So basically we need to find that. So if we go ASM file.open, can I do open text with an offset? STREAM reader equals ASM file.open text reader reade.seek base stream, which is what I don't stream close create current encoding discard dispose end of stream equals get hash code get type initialize peak read async read block read line async read to end to string. Okay. Alright. That's fine. I will live. Here's what I'll do. For int line number 0, line number is less than start line number. Starting a line number. Oopsies. Line number plus reader dot read line. There we go. So now this should bring us when we get to here, we're gonna go so if, let's say starts on line 20, we're gonna start at line 0, line 1, we're gonna get to line 19, which is before start. And then we are going to go to line 20. Line number is going to be 20. 20 is equal to start number, so it's going to be false. We're at the line before. So we want to buy less than or equal to. Get to here. Reader is now on the line for start program. Read line will cause the reader to read start program. I'm guessing that's correct. So if I do console.write line, reader.read line. Do you want to go out, Lucy? Hold on. 1 second, guys. Do you want to walk, puppy? I mean, not walk. Go on. Sorry, guys. My dog wanted to get out of the room, which is fine. I get to hear reader is right. So, now we make a file. So if I go to build, rebuild, open, bin, debug, new, text document, beginning file, ASM. Yes, I want to change it. Edit. Start program. Lucy, you were the one who wanted to go on wanted to go out. Remember? I already fucked it up already. All right. Go to properties. Build. Debug. Build events. No, debug. Command line with arguments. Beginning file.asm. beginning file.asm. Start. Cool. Console write line is nothing. Cool, yo. Start line number is 1. Oh, is this what happens? Is this what I'm getting out? Okay, so the start, right. Because the start line number is 1. So it seems to start at 1, right? Oh, no, that's not what I want. No, okay. All right. Oh, okay, good. So I made a mistake here. Start at 0, right? Well, not at end of stream. Read line. So let's put a breakpoint here. Read line, start program. Yep, so return 1. So start line number is 1. That's cool. End would be 2. So now we open it again. We get a new, totally different stream. We start at line 0. Okay, right. Okay, so basically, so what's happening is the program is in 0 base notation, but the line numbers are starting at 1. So if I do that, right? Bum, bum. No, I don't need that to work. You're 1. Right. Okay, you started 1. Oh, come on. Lucy! Puppy! Come on. Fucker. God. Dog's like a cat. Just wants to get in and then wants to get out. And then wants to get in and then wants to get out. There we go. That's what I need. Okay, cool. Wonderful. So, wonderful. So now if we go to, so yeah, so this will be the start program, right? So now we want to get past the start program. All right, so now if we do this, at this point, at this point, we are 1 line past start program. If we do a read line here, we will read the line after start program. Cool. So now bool at the end. Done. Well, not done. Well, not done. Oh, this is the loop in half, isn't it? This is me a do while, huh? Do while Yeah, do while. You guys haven't seen that. The reason why we're doing the do while is to get rid of the loop in half problem. So it's read it once, do something, and then test. So do while string instruction equals reader dot read line. What would also be better is to put this all into memory as well. I'm gonna do that. If instruction dot equals end instruction. String comparison. No. String comparison dot ordinal ignore case. Done. It's true. Oh, then I'm just gonna do an if else here. So really a do while loop really doesn't help, does it? Because basically I want to read it, and basically if we're not done. Alright, so fuck this. This is not gonna be a do while. Fuck this shit, man. While not done. Read the instruction. If we don't, then we basically process the instruction. Else. Done. Done is equal to true, guys. Yay. Right? Right, guys? Alright, so, everyone, thank you so very much for watching. I am going to end the stream here. It is 8:57, 3 more minutes till 9. So what we got done was we found... I need to bookmark that site before I forget it. What I found is this great lecture notes by some professor. That was really cool. For the 68K processor. Make sure to view those more. We started programming. We added a lot of things like, so I made the assumption that there will be a start program and an end program. So that's there. And then I just kind of coded it up a little bit. I did a lot of checks to make sure things exist and things don't exist. As I build the program more, I'll start separating everything else into its own file, into its own class, all that good stuff. But anyway, everyone, this is that programming guy. I have at the moment I record videos and edit and release them every Sunday at noon. This stream, I stream every Monday from 8 p.m. to 9 p.m. Pacific Standard Time. This stream is going to be released on YouTube every Wednesday following that Sunday at noon. So prepare to watch out for that. Yes, phone, I know. Shut up. I have shirts available. Probably you'll see them next stream, I guess. But this was fun. This was enjoyable. I would like to do more. But unfortunately, I do need some time to relax before I actually get home, you know. But anyway, everyone, thank you all so very much for watching, and I will see you all next week.